Hi everyone, Mechanics of Materials, Chapter 5, Torsion. Let's observe if we have increasing continuous torsional torque on a cantilever solid shaft. So as you can see here, we do have a continuous torsional torque, and at the same time it's increasing in the amount from A to B. So let's see how we can approach this problem. We already know how to calculate the angle of twist of a single torsional torque applied at the free end of a solid circular shaft attached to a block at one end. It means it's fixed at one end, and that's phi is equal to TL over GJ. And also we reviewed if there is a continuous torsional torque applied uniquely all over the span, and in that sense we calculate to have like a TL squared, and that's a TL over GJ, two of them. If we consider T times L, one of them is equal to small t times length is capital T. So it tends to be TL over GJ, and then what? Two of them. And this time we want to see what is the effect of a continuous torsional torque, but at the same time an increasing one. So let's see how we can approach this problem. So if we cut our section like by the length of x and develop our equation like d phi this time is, if you look at the nature of the distribution, if the total length goes all the way to t at the end of triangle, it just gives us a distributed like t. So in the length of x, it's like a simple relation. A whole length goes by t, x goes by but. That's x over L times the distributed mm, continuous torsional torque. So that's x over L times t, then x dx gj. So that's our d phi. And if we just integrate that from 0 to all the way to the entire length of the shaft, so it just gives us, take the constant out and then integrate x squared dx, and it just gives us x cubed over third times the constant, whatever it is. So that's, I left that part for the constant, and from 0 to L. If you do so, it just gives you a angle of twist at the end by an increasing torsional torque is T L squared over 3GJ. And then what if we have like a decreasing, this time we want to see the effect of decreasing a decreasing continuous torsional torque which applied, and we want to calculate the angle of twist at the free end B. This time, again, due to simplicity, if we take our element from the free end like B, again, the intensity of torsional torque by the length of x is what you can see, XL over TA. It doesn't matter if it's T or TA. And then because the length start from the fixed support, we integrate it from here. So integration from 0 to L, intensity TA like the previous part, but this time look at the distance. This is L minus X. So if we are here, you have to subtract L because we continuous length from the origin. In that sense, now if you integrate this formula, it just gives you, take the constant out, and this is the equation you have to integrate it, Lx minus x squared in parentheses dx. So if you do so, it just gives you a phi b is equal to constant ta over or t over L gj, integration from 0 to L entire length Lx minus x squared dx. And if you do so, it just gives you TAL squared over 6GJ. And definitely this is smaller than previous case because the bigger chunk of torsion applies at the first part and will solve more problem. Thank you.